Welcome once again. So we are in the lecture series of Zener Diode, and here earlier we have seen that how Zener Diode works as a voltage regulator, and in our previous videos we have solved some numericals. Problem 1 we have solved, problem 2 we have solved, problem 3 also we have solved. So those who have not seen those videos, I'll put the link in the description box. Please see these videos. For each of the videos we have taken different type of numerical. So here also we'll be taking another numerical, and here our objective is to find the minimum and maximum input voltage for this particular circuit. Now what all are given here? It is given Vz, which is also equal to VL. So this is our VL, Vz and VL both are same, that is the concept of voltage regulation, which is given as 20 volts. Then we have the input resistance as 250 ohms and the load resistance as 2 kilo ohms, and the maximum Zener volt current, that is IZ max, is given as 30 milliampere. So that means we have to find the minimum and maximum value of the input voltage Vs. Now here see, Iz minimum is not given. So if Iz minimum is not given, we shall consider this as 0 milliampere, because that could be the minimum value of the Zener current, Iz minimum. So with this concept, let us proceed to solve this. So let us first find the IL, because whatever happens over here in our previous numerical, we have seen that VL and IL are not going to change if my RL is fixed. Now here RL value is fixed at 2 kilo ohms. So we can find IL as VL divided by RL. So that is equal to 20 volt divided by 2 kilo ohms. So as a result of that, we'll be getting it as 10 milliampere. So IL is fixed at 10 milliampere. So now under these circumstances, we find I value, which is I, or I minimum value, you can say. I minimum value should be IZ minimum plus IL. Since Iz minimum value is not given, so we are considering it as 0 milliampere. So I minimum could be equal to IL. So now if we have this value as IL, and now if we apply KVL here, we can write that Vs, that is equal to I into R plus Vz. So Vs minimum value will get for I minimum. Vs minimum is equal to I minimum into R plus Vz. So from this we can find Vs minimum value. I minimum we have taken as 0. So Vz is value is I minimum value, Iz minimum value we have taken as 0 milliampere. So I minimum value we are getting as 10 milliampere. So 10 into 250 plus this one we get 20 volt. So here if we solve this, we'll be getting Vs minimum value as 22.5 volt. So that is the minimum value of the supply voltage. Similarly, we can find the maximum value when we get I max. So I max is Iz max plus IL. Now IL is fixed, so that is 10 milliampere we have found earlier, and Iz max is given here as 30 milliampere. So as a result of that, I max we are getting as 40 milliampere. Now similarly, if we apply KVL here, if we apply KVL, we can write Vs, that is equal to I max into R plus Vz. So I max is given as 40 milliampere into R is given as 250 ohms plus 20 volt for Vz that is given. So Vs max we can get as, if we solve this, we can get it as 30 volt. So don't forget to put 10 to the power minus 3 here, because this is in milliampere. In previous case also, here we should use a 10 to the power minus 3 because this is in milliampere. Okay, so these are very minute things. We should not forget to put all these things. So now, as a result of that, what we find that for this given circuit, the input voltage could vary from 22.5 volt to 30 volt. For a fixed load voltage, load resistor, we can get this input voltage variable from 22.5 to 30 volt. So if it goes below 22.5 volt, the circuit will not work, and above 30 volt, then the circuit may get damaged. So this is another aspect of the line regulation. So we end here our discussion, and this was the last type of problem under the Zener diode. So if you find any other type of problem, you can tell me accordingly. I can show you how to solve it. Thank you very much.